Okay, welcome grade 11s to where I work through question 1 here. This is the second video. In the first video we decoded question 1. Now we're going to go and solve each one of these questions. It is a long video. In the description below are timestamps so you can skip ahead and jump to the questions that are of interest of you. Alright, let's get going. So, if we looked at this first question, we saw that it was just worth 2 marks, which meant it has to actually be fairly straightforward. And what we wanted to avoid was thinking, oh, well, I need to go and distribute in here. If we do that, we realize we're going to have x squared. We're going to have a quadratic equation, which I need to solve by either factorizing or the formula. And if I look closely, I realize they've already factorized this for me. They've written this as 6 times x times 2x plus 1, and it's equal to 0. So this is what we call the zero product rule, that if we are multiplying and we're getting an answer of 0, well then one of these things has to be a 0. Well, obviously 6 can't be 0, but my other factors could be 0. So in this one here, I realize that x could be equal to 0, 6 times 0 times, well that's going to give me a 0 output, or 2x plus 1. This bracket could be 0. Now, this is a value of x. Solve for x, x equals 0. But in this one here, we haven't actually got down to a value of x. We know we're looking for a value of x that will make this bracket equal to 0. So, if we go and solve this mini equation for x, what value of x will make this 0? We're going to subtract 1 from both sides. 2x is equal to negative 1, 0 minus 1. And then we're going to go and divide both sides by 2, in which case we see that x could be equal to negative a half. And that's where your 2 marks are. One for x equal to 0, and the other one for x equal to negative a half. Okay, when we looked at question 1.1.2, we saw immediately that this one decimal place, if we've got a quadratic equation, we can solve that by factors or formula, but as soon as I see this, it tells me my solutions, my values of x are irrational, and therefore I want to use the quadratic formula. I'm not going to be able to factorize this to solve for x. So, if we want to use the quadratic formula, we've already written this down in our question paper. X is equal to negative b plus or minus square root of b squared minus 4ac. All of that over 2a. Well, what are a, b, and c? Where do I get those from? I only can get those from if I put the original quadratic equation into standard form. Ax squared plus bx plus c equals to 0. I don't have this equation in standard form. I need to put it into standard form. So my first step here is to put it into standard form. It doesn't actually matter which side it's on, but if I've got x squared already on the left-hand side, then I'm going to subtract 5x from both sides and subtract 1 from both sides. And now I've got it in standard form. Okay, so let's look at what our a value is. Well, our a value is going to be equal to 2. The b value is going to be negative 5. And our c value is negative 1. Alright, so now we're ready to substitute into our quadratic formula. And remember, when we substitute, we must use brackets. Okay, so this is the negative of b, and b, especially if it's a negative number, which is exactly what we have here, we're going to have the negative of negative 5. So I go and I put in all my brackets. That's b squared minus 4 times my a brackets and my c also in brackets. All of that over 2 times a. Alright, so I have my b value is negative 5. B squared, negative 5 squared, a is 2, and c is negative 1, and my a value is 2. Then you're going to go and type that in your calculator, and when you type it in your calculator, you are very careful to take the positive and then the negative root. Okay, when you type it in, your calculator will give you the surd values, but we are interested in the decimals. So my first, if I convert the surd to the decimal, my first value for x is 2,686, and there's a whole bunch more decimals. It's an irrational number. Or if I take the negative root Now look at the decimals. I get negative 0,186. Now I go back and I check one decimal place. So I need to round this off to one decimal place. So the question is this going to stay as 2,6 or is it going to go up to 2,7? Well, 8, that's 5 or larger. So that means this needs to go up to 2,7. My second solution, is this going to stay negative 0,1 or is it going to go to negative 0,2? Well, again, this is at 5 or larger. So I'm going to be looking at negative 0,2. And those are my two solutions. Okay, where are the 4 marks allocated here? Well, we had to put it into standard form. I needed to see your substitution into the quadratic formula. And then we're looking at each one of your solutions correctly rounded off. If you did not follow that instruction to one decimal place, you're going to lose a mark, penalty 1 for rounding. So be careful to read those instructions and don't throw away marks because you didn't read carefully. Alright, question 1.1.3. Remember, this was our third equation, which we wanted to square both sides. That will get rid of that square. But before we can square both sides, we must isolate that root. In other words, I cannot square both sides while I've still got plus x there. It's going to make it much more difficult, if not impossible, for you to do it. So, my first step here is that I want to subtract x from both sides. So I've got the square root of x minus 3 is equal to 3 minus x. Now we are ready to go and square both sides. And when I square both sides, those two are inverses of each other and they will cancel each other out. However, so on this left hand side, we've got x minus 3. But on that right hand side, we are now squaring two terms. Don't get ahead of yourself here. This is FOIL. We are squaring two terms. We need to get 4 terms. So if we go and do FOIL here, you're going to get 3 times 3 is 9. My outers are negative 3x and my inners are also negative 3x. I get negative 6x. And my last term, negative times a negative is positive. X times x is x squared. Now what have I got? I've got a quadratic equation that we want to solve with factors or the formula. Either way, we want to get everything equal to 0. Since I've got a nice positive x squared here, I'm going to keep my x squared on the right hand side. I've got negative 6x, but I'm going to subtract this x, negative 7x. I've got positive 9, but I need to add 3 to both sides, positive 12. And all of that is equal to 0. We must have that equal to 0, otherwise nothing really follows from this. Now, this looks like we can factorize this. The factors of 12 that add up to negative 7, well, they'd be x minus 4 and x minus 3. That gives me positive 12, negative 4x, negative 7x. That's looking good. Now that I've got factors equal to 0, or the first factor, if x minus 4 equals 0, x would be equal to 4, or x minus 3 could be equal to 0, in which case x could be equal to 3. Now you may feel like you're done, but we said we need to remember in grade 11 to check both solutions. When we square both sides, we may introduce solutions which are not valid back in the original equation. So if we do a check here, you don't have to show this, but you must do. Okay, right. Can x equal to 4? On my left-hand side, and I'm going right back up into the original equation here, I'm going to have the square root of 4 minus 3, but then I need to add x. I need to add 4 again. Well, what does this give me? 4 minus 3 is 1. The square root of 1 is 1. And 1 plus 4, well, that's 5. But my right-hand side was given as 3. So therefore, x equals 4 is not a valid solution. That doesn't work back up in the original equation. All right, let me go and check. Does x equal to 3? Does that work up in the original equation? So on my left-hand side, I've got the square root of 3 minus 3 plus 3. So what happens now? I'm going to have 3 minus 3 is 0. The square root of 0 is 0. 0 plus 3 is 3. And my right-hand side, well, that is equal to 3. So therefore, x does equal 3. X equals 3 only. Where your marks allocated here is for correctly isolating the square root and then for correctly squaring both sides. Then you're looking at your standard form with your factors, and you must discard your solution. You must check that you've only got one solution here. There's your 5 marks. Okay, when we analyze question 1.1.4, we notice that we've got a quadratic inequality. And the big key words here was we needed critical values, and then we needed to look at the graph or the number line so that we can choose an interval of values that will make this original statement true. Okay, in order to find our CVs, most of the time we're going to look for our zeros. The CVs are our zeros, right? Where do we get 0 out? And to do that, we need to find our factors. So in the initial part, this is very similar to like solving it as if it was an equation. I'm going to take everything onto the left-hand side, x squared minus 6x. I'm going to subtract 7 from both sides. And then I get this, greater than or equal to 0. Now, that also means something to us. This greater than or equal to 0 is how we write in grade 11 that I want that expression with x to be positive. I want to know what values of x will make this trinomial positive. That's when we're using our graph or the number line, we're looking for positive outputs. Okay, now to find our CVs, we can factorize this. And almost always you'll be able to factorize your quadratic inequalities. So we get x minus 7 and x plus 1 to get negative 6 and negative 7 as my last term. Now, we don't want to go and say x equals 7 and x equals negative 1. These are critical values. All that we care about right now is that this is where a graph will be 0. This is where this function changes from being positive to negative. So we're going to use those critical values either as a graph where I've got negative 1, positive 7, and if I look at this as a graph, this is an x squared, this is a happy positive shaped parabola. That's the shape I'm looking at. Going back here, remember we wanted the positive part of the graph. The positive part of the graph is where the graph is above the x-axis. So I'm choosing the x values less than negative 1 and greater than 7 because that produces positive outputs, and that's what we wanted originally. So now that I see that, I'm going to draw a number line here to make sure I understand x is less than negative 1 or x is greater than 7. Can we include negative 1 and 7? What happens at negative 1 and 7? Well, these are my zeros. This is where my output is 0. So yes, it can equal to 0. So we include those outputs. Now, that's represented on a number line. How do we represent this in maths notation? Solve for x. What are these x values? X is less than or equal to negative 1, or you have to have this. It is a totally different interval of numbers. X is greater than or equal to 7. Okay. If instead of using the graph, you can also use just a number line and substitute values smaller than negative 1, numbers in between negative 1 and 7, and numbers larger than 7. And you're looking then if the outputs are positive or negative, and you'll get the same interval of solutions. When we analyze question 1.1.5, we notice that x was in the exponent. So this is an exponential equation where we normally solve those by trying to get the same base on both sides. Now, as soon as we're involved with exponents, we're thinking about our exponential laws, and then we notice that as soon as I see those terms there, I realize that that's addition, and I don't have exponential laws that work with addition and subtraction. My exponential laws work with multiplication and division. So how do I make multiplication and division? Well, we need to factorize. Now, it doesn't look like anything factorizes yet, and that's because we haven't written our bases with prime bases. So this 25 and that 125, our first thing is going to be to write those with prime bases, and then we look at how we can factorize. So 5 to the x, 25, well, I'm going to rewrite this as 5 squared to the power of x. 125, that's 5 cubed to the power of 5x plus 1. Do we see anything that we can factorize on that left-hand side? Well, if we simplify using law 3, 2 times x is 2x. Believe it or not, on that left-hand side, we have a highest common factor of 5 to the x. Can you see it? Can we divide 5 to the 2x by 5 to the x? Well, if you can't see it, you might have wanted to write 5 to the 2x in a couple of ways. One way we can write it is to reverse the order of multiplication and to see this as 5 to the x squared. X times 2, 2 times x. So therefore, now I've got 5 to the x. Well, 5 to the x definitely goes into 5 to the x squared. Or you could have even seen it as 5 to the x times 5 to the x. X plus x is 2x. In which case I can definitely see that 5 to the x is a common factor. So if I take 5 to the x as a common factor out, something very interesting is left over. Do you notice that these brackets are the same? Now the question is, are you allowed to go and divide both sides by that bracket? Is this an okay thing to do? Now we've taught you don't want to go and divide by a letter. If you go back up to this original equation 1.1.2, you don't want to go and divide by x squared there. You're going to lose solutions then, even if it's possible. So when are we allowed to divide by this one? Well, when we know that this cannot equal 0. Do you know why 5 to the x plus 1 can't equal 0? If you do, well then you can go and divide by 5 to the x plus 1 and make this a lot simpler. If you're not sure, well then we're going to play it safer and we're going to keep on trying to look to factorize. So I'm keeping this first factor here, and then I'm going to subtract this whole right-hand side, 5 cubed times 5 to the x plus 1. We're going to make that equal to 0, because now I see that that bracket is common. And what am I left with? 5 to the x from the first term minus 5 cubed from the second term, and all of that is equal to 0. So I've got something like a quadratic equation. I've got two factors multiplied, give me 0. So can 5 to the x plus 1 equal 0? Or 5 to the x minus 5 cubed, can that equal 0? Well here, 5 to the x equals negative 1. Now, it goes back to this pink idea over here. 5 to the x is an exponential function. In fact, this asymptote is at 1. You've moved it up, which means it can never be 0. And here it means that 5 to the power of x, there's no value of x, 5 to the power of anything. That cannot never give me negative 1. This can never even equal 0. So there's no solution to that branch. So you could have gone and divided by 5 to the x plus 1. And if you'd done that, you'd be left with only the second part here. If we go and solve this by adding 5 cubed to both sides, we can now see that we're back up to this original idea that I've got the same base on both sides, and therefore those exponents have to be equal. And that's my solution. Okay, question 1.2. And we notice here that we've got 6 marks here. All right, so this can be good if we know what we're doing, and if we don't know what we're doing, it's going to hurt us badly. The good news is that we've seen this quite often. We've seen this question before. We've got two letters, x and y. We want to try and find our final answer. Needs to be x is equal to a number and y is equal to a number. When we saw that we had squares, we might have another pair to say x could be this number and y could be this number. How do we solve for two letters? Well, we want to try and create an equation that has only one letter. I'm going to write these equations next to each other. What can we do so that one of these equations has only x's or only y's in? Well, in this first equation, I'm seeing that I can write it in terms of x fairly easily by subtracting 2y from both sides. Now what that means is that this x here has to represent the same number as both of those x's. So therefore, I can go and replace this x with the expression 1 minus 2y. And I can replace that x with the expression 1 minus 2y. But when we replace, and especially considering that we've got two terms here, we must keep that term and those terms in brackets. So we're saying x squared means 1 minus 2y squared plus y squared plus 3 times that x value, 1 minus 2y. But then we still need to multiply it by y, 3xy. And then finally, we have to add that y. Okay, what do we see now? Well, the first thing here is we've got to be so careful. Here, we are squaring the bracket again. Here, this is FOIL. So we're going to write that bracket twice. 1 minus 2y times 1 minus 2y. Shortcuts might get you into so much trouble here. So let's be safe. Y squared. And then what do we notice here? We're multiplying 3 by the bracket and then by y. Well, remember the order that we multiply doesn't matter. So it might help you if we wrote it as 3 times y and then times the bracket. Then we don't forget that we still have to add y at the end and we get an answer of 0. If we go and do FOIL here, 1 times 1 is 1. My outers, negative 2y, and my inners are also negative 2y. Negative 4y. My last terms, positive, because of negative times negative, 4, y times y, y squared, plus another y squared. Now, we need to distribute in here, positive 3y times 1, and then we're going to get positive times a negative, 3 times 2 is 6, y times y is y squared, plus y, equals 0. Okay. Let's go and look here. My like terms, 4y squareds plus another y squared, that's 5y squareds. But then I'm taking 6 of them away. I've got negative 1 y squared. My y's, negative 4y plus 3y is negative 1y. Negative 1 plus another 1, well, that's 0 y's. I don't have any y's left. But I do have just one constant. What have you got here? You've got a quadratic equation again, which we want to solve with factors or the formula. Well, this one here looks a little bit familiar. Either you can divide out a negative, or you can take everything onto the right-hand side by adding y squared and subtracting 1. This gives me a difference of 2 squares, y plus 1, y minus 1. Therefore, y equals negative 1 in the first bracket, or y equals positive 1 in the second bracket. Now, we're not done. We've solved for y, but we still need to solve for x. So I'm going to take these values back into my expression for x. If y is negative 1, I'm going to have 1 minus 2 times negative 1, 2 times y. In this case here, I'm going to have 1 plus 2, 3. So if y is equal to negative 1, then the x value is equal to 3. What happens if my y value is positive 1? X will equal 1 minus 2 times positive 1. If y is equal to positive 1, then x is equal to negative 1. So you have this pair of solutions, or you have that pair of solutions there. I know this seems like a lot of work, but we're giving you a lot of marks here, so be careful. Take your time, make sure. First mark is for correctly isolating x. The second mark is for correctly substituting it in, being very careful to substitute in both places. The third mark is for getting down to a standard form. The fourth mark is for your factors, the fifth mark for your y values, and your sixth mark for your x values. Don't go and make grade 9 errors. From this to this here is grade 9 algebra. Be careful, be systematic, be accurate. Alright, when we analyze this question here, we said if a function is equal to 0, well, these here are my x-intercepts, which is also another way of talking about roots. And we said this expression looks just like my quadratic formula, which gives me my actual roots. But now we don't want to know what the roots are. They said here, I just want the type of roots. I want non-real roots. I want to look at the values of k. In other words, solving for k that gives these answers here as non-real roots. Normally, when we think about roots, we think about delta. We think about delta as b squared minus 4ac. Except in this case, we don't know what the values of a, b, and c are. And in fact, we realize that we don't need to, because we realize that the part under the square root, that is what delta is. So in this case here, we realize that delta in this expression is 3 minus 12k. That's going to determine what type of roots you get for x. Now, if we want non-real roots, we know that the part under the square root delta must be negative, not equal to 0, less than 0. And so therefore, we're going to take our expression 3 minus 12k, and we're going to look at what values of k would make that negative. So now we have created a linear, because it's just k, not k squared, inequality. And how do we solve a linear inequality? Well, then we can get k is less than or k is greater than. We can isolate k, just like we did in an equation. So how we isolate k here? Well, I might want to go and subtract 3 from both sides. So I'm going to get negative 3. But now what are we going to do? You're going to have to divide by a negative. And this is the one rule with inequalities. If we multiply or divide by a negative, we need to change the direction. Why? Well, if you had negative 5 and positive 3, which of these two is larger? 3 is greater. But if you went and changed negative 5 to positive 5 by dividing or multiplying by negative 1, then I'd have to do the same thing on this side, negative 3. Now which way? Well, therefore 5 is greater than negative 3. So if I want to go and divide both sides by negative 12, I need to change the direction. Negative 3 divided by negative 12 is positive 1/4. Now, if you wanted to avoid doing that from this here, you can avoid doing that by keeping the 3 on the left-hand side and adding 12k to both sides. If I add or subtract, so if you go and add or subtract anything here, so let's go and add 1 here and add 1 here, then your relationship stays the same. 6 is greater than negative 2. So if you just can keep your operations to adding or subtracting, you don't have to worry about changing the direction. 3 divided by 12 is 1/4, and 1/4 is less than k. Well, that's the same way as saying k is greater than 1/4. These two things here are exactly the same. So either one of those answers is acceptable. Okay, the last one. And as we discussed, this might be difficult. This might be unfamiliar. We might have to think outside the box a little bit. Let's try and make sure we understand the given information. The given information, first thing, it talks about a range of possible values for x. In other words, they're giving us here almost like restrictions. They're giving us an interval. X is something where x is between negative 4 and positive 3. And the same way in the second one here, we've got a restriction on y. We've got a restriction on y to say that y is between greater than negative 5 but less than 4. Question 1.4.1 asks for the largest possible value of x squared. So x, we are looking at x values. So here we are focusing only on x values. So we are looking at when x is between negative 4 and positive 3, we want to get the largest possible value of x squared. So let's go and try some numbers here. If we take 3 and we square it, that's x squared, we get 9. Is that the largest possible number? Well, it's certainly bigger than taking 2. Remember, x can be any number between negative 4 and 3. 2 squared would be 4. Yeah, so this is larger. But remember, if we take a negative number, So let's go all the way down. The smallest value, negative 4 squared. When I take that x value and I square it, I get positive 16. Suddenly now 9 is not the largest number. 16 is the largest value of x squared. So what's the largest possible value of x squared? Well, if x was negative 4, the largest possible value of x squared would be 16. Make sure you've answered that question. All right, question 1.4.2. What's the smallest possible value? Okay, so now we're looking at smallest possible value of x times y. So now we need to take an x value, but we're going to multiply it by a y value. So you need to take a number from the set of x and a number from the set of y, and we want to get the smallest possible value. And remember we spoke about, well, is the smallest possible value equal to 0? No, because we know from our number line that we can have smaller numbers which are negative. In fact, the more negative it is, the smaller the number is. So when I'm multiplying two things here, we want to look at making it very negative. In other words, we want to take a negative number, multiply by a positive number. And we want to try and get the most negative answer. So let's go and try some numbers here. What happens if we tried from our x values, we tried negative 4 from our x values. And if I've taken, that's the smallest negative from our y values, I'm going to go and choose the largest positive value. That gives me negative 16. Well, is this the smallest possible value? If I took negative 3, which is a larger number, and we took it, multiplied it by the 4, well, you get negative 12. That's not smaller than negative 16, so this is still the smallest number. But you might be thinking, well, what happens if I took a positive number from the x values, like positive 3, and I multiplied it by that very negative 5. What does this give me? This gives me negative 15. Is this larger than negative 16 or smaller? Here's negative 15, and negative 16 is further left. So this here is the smallest possible value of x times y. The smallest possible value of x times y is negative 16. That's when x is negative 4 and the y value is positive 4. Okay, the last question, 1.4.3. What is the value of y if y squared is equal to 25? Well, if y squared is equal to 25, then we know that y can be either positive 5 or negative 5. But remember, we are given restrictions on what y can be. And if we look at our restrictions for y, we see that y has to be between negative 5 and positive 4. So therefore, positive 5 is not in the domain or not in the interval of y values. Therefore, the only y value that is true, that when you square it, you get 25 based on the restriction, is when y is negative 5. And that's your answer. Right, grade 11s, well done for making it through that. I hope that it was helpful. We're going to put up some more practice for equations and inequalities. You can never do enough practice. There's the cycle test already up there, which had from last year, and we'll put up the June exam from last year as well. But keep practicing. Make sure you start off your exams on a good note with question 1.